NASA sent a spacecraft right into the sun. It's the fastest human-made object ever, and could cover the distance from Philadelphia to Washington, D.C. in just 1 second. The Parker Solar Probe's mission is to study our star's dangerous behavior. Scientists warn that massive solar storms are inevitable, and the consequences could be catastrophic for our planet. The spacecraft got 7 times closer to the sun than any other probe ever did. It managed to do so during its 20-second flyby to the star since its launch in 2018. Because our star is so massive, its gravity is really strong, like a giant magnet. As the probe flies around the sun, it uses gravity to go faster and faster and eventually picks up that crazy speed. As it got closer and closer to the sun's corona, which is its outer atmosphere, the probe had to survive temperatures of 2,552 degrees Fahrenheit. That's hot enough to melt many metals. It was protected from that heat and radiation by a 4.5-inch thick carbon shield. It kept the tools inside the probe safe and running at around room temperature. The scientists went to all this effort because they're hoping to solve a big mystery about the sun that's been puzzling them for ages. The surface of our main star is already super hot, but as you move closer out to the corona, the temperature shoots up to millions of degrees. And it doesn't make any sense because it's farther away from the sun. So maybe we could finally get some answers about this heat phenomenon. The mission is also going to help us understand something called solar wind. The sun is constantly shooting out tiny bits of energy and charged particles into space, like a never-ending breeze of electricity. When this solar wind hits Earth, it can create amazing light shows in the sky called auroras. The more active the sun is, the farther south you can see auroras. Our star follows natural cycles that last about 11 years. The activity goes from low to high and back down to low. Right now, we're in the solar maximum, the peak of the activity cycle. That's why we've spotted beautiful auroras in the most unexpected places in 2024. The downside to it is that the sun's activity can send out bursts of energy and charged particles that can mess up things like radios, satellites, and even GPS. It can be dangerous, especially for astronauts out in space who aren't as protected as we are here on Earth. Humans wouldn't feel the compression of the planet's electromagnetic field because of all the extra radiation, but power grids are really sensitive to it. If we don't act fast when it happens, the influx of energy will go into power transformers all over the world, disrupt them, and leave big areas without electricity. If this happens during a hurricane or a tornado, when communication is already super important, it could make it much harder for emergency services to communicate and save lives. That's why it's so important to learn to predict this space weather. It's tricky because, unlike most disasters, like earthquakes, floods, and volcanoes, it doesn't leave behind any kind of physical evidence. The only big solar storms we really know about happened in 1859 and 1921. The first one, called the Carrington event, was so wild that it made sparks fly from telegraph wires. The auroras were seen all the way near the equator. Scientists back then were using a special kind of paper that reacted to light to record solar activity. During the Carrington event, the reading from the sun went off the page, literally. Whatever was happening, it was so extreme that we still don't fully understand it. Then, there was the New York Railroad Storm of 1921. It was powerful enough to knock out telegraph systems across the US, Europe, and the Southern Hemisphere. The storm boosted radio transmissions for a bit, making them travel farther than usual. But back then, there weren't nearly as many radios, so it wasn't super helpful. The bigger problem was the electrical grid in the US, which was heavily damaged. Back in 1859 and 1921, people weren't as dependent on tech as we are now. If a storm like that hits today, the consequences could be way more catastrophic. Scientists from New Zealand who study space weather are working on simulations trying to prevent disasters from happening. They say one of the possible options to do it is to study other suns like ours elsewhere in space. If we get data from thousands of stars, not just one, the picture for analysis would be more complete. So far, scientists have launched or plan to launch several other missions in addition to the Parker Solar Probe. Meanwhile, NASA is working on another mission, launching Endurance, robotic moon machinery on steroids. Its main mission will be to collect samples from key lunar locations that will later be retrieved by astronauts from the Artemis program. These samples are spread across the largest impact basin on the Moon, separated by hundreds of miles. To do it, Endurance will have to be way more advanced than Perseverance, NASA's current most cutting-edge rover. Endurance will drive roughly 100 times further, drive 10 times faster, and collect roughly 200 times more sample mass. Endurance would also be the first planetary rover to drive at night. And because it will be on the far side of the Moon with limited communication to Earth and surface data, it will have to drive autonomously between sample locks and make its own decisions in tough conditions. When it reaches its destination, it's going to switch to a more classic way of doing things. Scientists back on Earth will get involved directly, guiding the rover to explore the sites and collect samples. The teams on Earth will also keep an eye on how the rover is doing by monitoring its telemetry, which is the data it sends back, like its health stats. If they spot any signs that a part is wearing out or something isn't working quite right, they'll tweak the plan to keep things running smoothly. All this will cost huge amounts of money, probably way more than the Viper moon mission that was cancelled after NASA had spent around $450 million on it. While Endurance is in the planning stage, the Blue Ghost lunar lander is already on its way to the Moon. Its main mission is research. It will spend 25 days in Earth's orbit, taking measurements and waiting for the right time to fling itself to the Moon. After 4 days in transit, Blue Ghost will hang out in lunar orbit for another 16 days to collect more data. Then it will descend to one of the largest basins on the Moon and spend one lunar day there. It will measure subsurface thermal data, radiation levels, and other important data. At the end of its mission, Blue Ghost will take some final pictures of the lunar sunset. It isn't designed to return back to our planet, so when the night falls, it will do some final work and go offline for good. NASA chose the team of University of Florida aerospace engineers to work on another innovative space project. It will cost $12 million, and its goal will be to improve the way we track changes in tectonic plates and oceans on Earth from space. It will use state-of-the-art sensors that will measure even the tiniest gravitational changes. The data it gets will help scientists monitor droughts, assess groundwater reserves, and better understand changes in sea levels. They expect to launch it around 2027 aboard a SpaceX Falcon 9 rocket.
That's it for today. So hey, if you pacified your curiosity, then give the video a like and share it with your friends. Or if you want more, just click on these videos and stay on the bright side.